Let's take a look at how to prove something. We're going to look at how we can prove angles in this case. Am I going to focus on proofs? No, I'm not. But you have to see them. You have to understand a little bit about them. I'm going to tell you as we get into geometry further and further, it's going to be more learning about how to deal with angles, shapes, and that type of stuff in the more analytical geometry than it is going to be in the theorem geometry, which this is theorem geometry. All right? All right. A theorem, let me read this for you. A theorem is a conjecture or statement. Listen up. Enough. When I'm talking, stop. A theorem is a conjecture or statement that you prove true using deductive reasoning. We've gone through and done deductive reasoning now in this chapter. We've had it, all right? You've said, if this is true, then this is true. That's deductive reasoning. If you prove each step using any of the following given information, definition, properties, postulates, or previously proven theorems. In other words, something that you know is true, you could use in your proof. The proof is a chain of logic. Each step is justified, and then the laws of detachment and synergism connect the steps to prove the theorem. Vertical angles are angles on opposite sides of two intersecting lines. We know that, right? We know what a vertical angle is, right? We've had that definition before. What's a vertical angle? Amber? What's a vertical angle? Two lines cross. It's the angles that are opposite each other. Okay, so we know that to be true. In figure to the right, angle 1 and angle 3, these two angles right here are vertical angles. All right? We know that 2 and 4 are also vertical angles. The vertical angle theorem states that the vertical angles are congruent. We have a theorem that already states that if vertical angles are equal to each other, they're congruent. All right? So if we take a look now at this proof, it says given the measurement of BOF, a BOF, all right, given that measurement, is equal to FOD. What does it mean that these angles are doing then? If they're equal to each other, then this angle equals this angle, right? We know that right away. Prove that 2 times BOF equals AOE. So 2 times is BOF equals this whole angle. Logically, it tells you that, right? But we have to prove that. That's what we're going to get into. Given. This is the given statement. You always start a proof off with given. You're doing a proof, you start with given. So, our first one here is given. That angle BOH equals FOD. This is given. We know that angle BOF plus FOD equals BOD, right? Because this angle plus this angle equals this big angle. True? How do we know that? Through the angle addition postulate. The angle addition postulate is what we just did on this last section. Right? The angle addition postulate. Now, BOF plus BOF equals BOD, right? BOF plus BOF equals BOD. Why can we say that? It's through the substitution. We can do the substitution property on that. We're substituting in. Why? Because BOF, look at this, BOF equals FOD, right? So let's substitute in for FOD right here, BOF. Because it's the same angle, right? We said it's the same angle because it's given right here. So we substitute. What's the next thing we do? Well, we know that if we add these together, 2 times this, right? It's like if this was x and this was x, this would be 2x. We have 2 of the angle of this equals BOD. So 2 times this equals BOD. Combine like terms. We've done this in algebra. Combine like terms. The next one is angle AOE. E is congruent to BOD. So this one here is congruent to this one here. Why? Because of the vertical angles are congruent. The vertical angle theorem. So if AOE is congruent to BOD, the definition of congruency, right? Same thing, the measurement. If the angles are equal, then the measurements are equal. And the last one is, then if that's the case, through this right here, 2 times the measurement of BOF is equal to AOE. That's what we were looking to prove, substitution property, and we've proved this, what they're asking for right here. It's a lot. It takes some thinking. But just like any other math problem, you break it down step by step. No, it really doesn't. No, we're going to do both pages. So, here's what you're going to have to prove. Use this as an example. You are going to have to prove that it's given that angle AOB and angle XOZ are vertical angles. What does that mean? That they're opposite each other, right? This one and this one. And that angle AOB is 80 degrees. Let's say this is AOB, and this is 80 degrees right here. Okay? And we know that XOZ right here is really what? 6x plus 5. You have to do it in a proof, though. You have to show that x equals in a proof type way, which is really doing what? Explaining what each one of your steps are into doing this equation. That doesn't work because that's not proving it. You have to prove it through steps like this using things like angle addition postulate, substitution, and you're going to use your other postulates and theorems and you're looking at it from the analytical side of things. You have to look at it from the theorem side of things. You're theorizing all this. So what it is, right now, we just use angles like this. Now they're going to take an equation, but you have to work with it, and you have to tell each step on that equation what you're doing. Are you substituting? Are you dividing? Are you adding? Are you subtracting? Are you doing what property to be able each time you do this? That's number one. Only if you're lucky. All right, what happened? There we go. All right, come on down. All right. On the back side, on the next sheet, we're not proving here. What are we doing? We're doing an analytical find of each value, right? We're analytically doing it, like analytically means we're actually doing the math, all right, to find out what y is going to be. We're going to set, we have two vertical angles, we set these equal to each other, and we solve for y. All right, you did this in algebra, you'll be able to do this here. All right, let's see, what do we want to do? Congruent supplements. If two angles are supplements of the same angle or congruent angles, then the two angles are congruent. Work on the first four. Do the first four. I want you to do the proof, and I want you to do the first four out of this section. All right? So do one, and then come over here, and I want you to figure 2, 3, and 4 out.